Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So let's see today's daily challenge on Leetcode and let's try to solve it together. So today's challenge is definitely a little bit difficult one, but first let's understand the problem. So I guess understanding the problem is very easy in this question because it's very much visually appealing that you are given a 3D grid actually. The matrix which you are given is a 2D matrix which consists of heights. So it's basically a 3D structure, and after all the raining has happened, so after all the raining, okay, you need to find how much rainwater gets trapped. Okay, so in this structure how much rainwater can get trapped. So yeah, and the constraint are given to be something like this. So how should we approach these problems? Okay, so this is definitely an intuitively hard problem, and yeah, I do not blame you if you were not able to solve this, but stay till the end of the video and I'm sure you will definitely catch this approach. So yeah, by first looking at the problem, how will you think? Okay, so first you see what is given in this question. It's given a height map. Okay, so you are given basically a 2D grid. Okay, and in this 2D grid you are given the structure of this whole thing. Okay, so let's say this number of rows are m rows, we have m rows and n columns, and each of the grid is nothing but a height. Okay, so that's how it's the structure is told. Okay, so now the first things which comes to your mind is that let's say I have a very small grid. Okay, let's say I have a very small grid, and if I have some boundary cells, okay, I'm just telling you just for the sake of intuition, is that if I have some boundary cells, let's say, and I want to store some water here. Okay, so what I want to do is basically I will store some water here. So what will be your basic intuition is that let's say the height of this is 5, 6, 4, 8, 8, 9, 11, and let's say maybe 12. Okay, so what should be the height of this cell if you want to store something at least? If you want to store something at least, so you see the level of this is bounded by these 4 cells, 6, 8, 8, 11, not by these 4. Okay, that I hope that is very clear, because no water can seep in through the diagonal values. Okay, so so if you want to see the neighboring cells, what are the neighboring cells of the my target points? My neighboring cells are 6, 8, 8, 11, and in order to store a minimum amount of water at least, it should be less than 6. So the height of my target cell, so I am just telling that the height of this ij, this should be less than 6. In order to store, it should be 5 or it should be 4. There are only integer values. Okay, it's already told in the question. So it should be less than this, then only it is able to store, otherwise it will seep through the boundary and it will not be able to store anything. Okay, so the thing which you get in this problem is that the first observation was this, definitely. Okay, this was your first observation, that within the boundary the minimum value is the thing, okay, which you need to take care of, and it should be less than the minimum value. Now every time you need to find the minimum value only. Now you see, if you try to see this boundary, this grid as a whole, it's not only a 3x3 grid, right? It is a big thing. So if you try to see this in terms of the boundary, you see nothing should be able to, in order to fill it completely, nothing should be able to seep out. Okay, so no water, what I'm trying to say is that within this boundary, within this particular boundary, no water should be able to seep out. No water should be able to go out through this boundary by any direction. Okay, so it must be constrained by this boundary limits. So what I can do is that I can see that, let's say this is my one of my boundary cell. I will see, let's say I will just keep a track that which is my current minimum boundary. Okay, so what I want to say is that since my first observations tells me that my minimum boundary is the thing which I need to take care of, so I will just tell that you go to the cell among all of these cells. So among all of these cells, okay, whichever has the minimum height, you go to that, because that will only ensure whether the water is stopping or not. Okay, because you need to be lower than that. Okay, now you go to the minimum height. Let's say the minimum height lies somewhere here. Okay, so I went to this position. Let's say I am going to this position where the minimum height of the cell is. Now I will see what are the neighboring cells. So what is the neighboring cell in the grid? It is only this. Now I will see that if this neighboring cell height, is less than this boundary cell, minimum boundary cell height. This is the minimum boundary cell height, right? All other boundary cells are definitely greater than this. So if this is even minimum than this, then I can store some amount of water. So what is the amount of water? If the height is x and let's say this height is h and x is greater than h, then definitely the amount of water which I can store is x minus h. Now you might be thinking that, hey, but what are you doing exactly? Because these elements you haven't seen yet. These elements you haven't seen yet. So what did I do is that you see, ultimate boundary limit is the whole grid, right? If you even if you are thinking that it will seep into these cells, but if you see the if you try to hold the whole structure with water, definitely this is the minimum uh, height which will be added. Okay, this will be the height which will be added. And now you see what I will do after this is that let's say I have filled one cell. Okay, so what will I do right now is that let me use the same color. So yeah, I will what I am just trying to say is that uh, this is the cell which I just now filled. Okay, this is the cell which I just now filled with water. Okay, so maybe I filled or maybe I did not fill, maybe if its height is much more I did not fill anything. Okay, so that's what so you see I went to the minimum cell and I just filled this value. Now this, let's say I am trying to see the side view, try to visualize. I know this is quite difficult to visualize, but yeah, try the thing. If I try to see that, let's say the height of this is, let's say maybe 3. Okay, the height of this cell is, let's say maybe 3, and some amount of water is also trapped. Let's say the height of the water is 2. Now you see the net height of this boundary. You have already made sure that this, at least this water will definitely stay in this whole grid, because the whole boundary is global minimum neighbor you are trying to calculate. Okay, so okay, so I'll just do this. Okay, so I hope you do understand. Now this height of water also acts as a wall. This height of water also acts as a wall, and in order to prevent leakage, I must try to figure the neighboring cells, the neighboring to this, whichever cells which are neighboring to this must lie less than or equal to this cell. Okay, less than or equal to this cell. So what I will do is that I will take this height, I will take this height and also push. So where will I push? So you see, you get the idea of a priority queue or a heap. Okay, if you don't know already what is priority queue or heap, you can just quickly Google it out. It is a very useful data structure. It gives you the minimum element. So in I told you that you need the minimum boundary, right? So you do not need to iterate through your boundary array again and again. You can just keep your minimum heap priority queue, which will give you the minimum element at the top. Okay, the top of the priority queue, which will give you the minimum element. So you store it in a min heap. It is basically a min heap. Okay, and by default a priority queue stores as max heap, but you need to make it a min heap by height, and you will directly get the minimum element, and you will also push this element. You will also make this part of your boundary. Okay, make this part of your boundary, make this part of boundary to prevent water leakage. Okay, to prevent water leakage. So I hope at least some sense is making to you. As I will code the things out, it will become more clear. And the very interesting thing is that you see the boundaries get shrinked. The boundaries get shrinked from all sides. You will just keep on shrinking the boundaries. You will just keep on picking the height, minimum height which is there in the boundary, and you will just keep on shrinking it. And in every time you will just calculate that what is the amount of water that can be stored in this cell, that cell, and you will just be adding your total value to the answer, and the answer will beautifully come out. Okay, so I will just go through the code. Okay, I will just write the code from scratch actually, so that things are very clear to you. Now I hope you do understand in I am using a priority queue here, and I am pushing all the elements in this, all the boundary elements at first. Okay, so the things which I will do at first, it's quite obvious by now, is that push all boundary elements in the priority queue. Okay, boundary elements in the min heap. I will just push all my boundary elements in the min heap, and yeah, that I will do first, and I will just try to see the neighboring elements. Okay, see the neighboring elements and calculate the height of water, the amount of water which can be stored. Okay, and calculate height of water stored. So extra height which is stored, I will just calculate that. And so yeah, what do I need to store in the priority queue? So I will have my priority queue to be something like height, the cell ith row and jth column. Okay, this is the format in which I will be storing the priority queue. So this is nothing but a vector of length 3. This is a triplet, so this is a vector only. And so yeah, that is what it. Okay, and now in order to traverse the 4 directions, I will use a direction vector also. I hope you already know about these direction vectors in graph problems. Okay, so I want to use these 4 directions. So if my cell is I comma j, this cell, what will be this cell? This will be I plus 1j. Okay, I hope you do understand, right? This will be I minus 1j. This will be I j plus 1. I j plus 1. This will be I comma j minus 1. Okay, these will be my boundary cells. So I am adding to my boundary cells to be something like this directions vector. Okay, I will make a direction vector like this. So let me first make it and make it a global variable. Okay, so I will just have a vector of vector int. I have already explained in many of the graph problems before that how this direction vector is actually working. You will also understand in this code again. So yeah, this is 0 minus 1, and it will be 1 0 again, and also it will be minus 1 0. So I hope you do get the direction vector understanding. Okay, so yeah, what will I say is that you have, let's say, m rows and n columns. Okay, so I will take that to be the standard method. Okay, so I will take this to be the convention, is that there are m rows and n columns. So columns will be represented by something like this. Okay, so yeah, you have it right now in front of you. And yeah, now you need to have a boundary element. Okay, you need to have a boundary priority queue. Now if you don't know how to initialize a priority queue, just quickly search for it in the gigs for gigs. I will just quickly write. So in order to do a max heap, you write something like this. Let's say this will be boundary. This is a max heap, okay, of integers. For a min heap, you need to initialize it something like this: int vector of int greater of int. Okay, this integer contains the data type which you want to store. Now what is the data type in my boundary? In my boundary, if you notice, my data type is itself a vector. Okay, so instead of this integer, I will write a vector. I hope this is clear to you. If you already know how to initialize a priority queue, I hope this will be very clear to you. Otherwise you can just Google it out. Okay, so yeah, I'm not wasting much time in the initialization and making you understand this. I hope this was trivial at least. This you should be able to understand. Yeah, so you initialize the priority queue, which is nothing but a min heap, which will always contain the minimum element in the top, and you can access that in O of 1 time, and you can push the elements in O of log n time. So that's why this is a very useful data structure. Every time you do not need to iterate through your array to find which is the minimum element. You can just find it very trivially from the top element. Okay, so what are the things which I need to push in my boundary is that, so you see, at first I will push my boundary elements, right? So what I can do is that I have this, and I need to push these cells, and I also need to push these cells. Okay, so at first what I will do, I will go through 0 to m, m minus 1, let's say, and I will push these elements. This will be my I iterating variable. I will iterate from 0 to n minus 1, and I will push this j 0 and this jn minus 1, only these two cells. These two cells I will keep pushing in this way. Okay, so in this way I will be adding all my vertical values, vertical boundary elements to my priority queue, and after that I will just add these values. Okay, so yeah, I hope that is not at all difficult for you. So I will just go from 1 to m I, and I will just push things into my priority queue. So I also need a visited vector, right? So you, by now you would have easily understood that I am doing a type of BFS. So yeah, I need a visited vector so that I do not lose track of which elements I have already visited. Okay, so yeah, so it will be a vector of vector, and it will be initialized with all zeros, meaning that all the cells are right now unvisited. So yeah, you have this, and what you can do very easily is that you can write boundary, this boundary element dot push to be something like what will be the first value? First value will be the height, right? So the height will be nothing but it will have this I, and the second element will be 0 at first. Okay, and what will be the coordinates? It will be I comma 0, nothing fancy. Okay, so I hope you do understand what I'm trying to do, and I will just have an n minus 1 here and an n minus 1 here too. So yeah, I just added the element in the exact manner as I told you, and I will also update my, okay, so should I update the visited value? What do you think? Should I right now update the visited value? This is because I should do this because you see in the boundary elements you cannot store any water. Okay, uh, because of obvious reasons, because it will, I mean, it will seep out, right? It will not stay. Okay, so you need to just initialize that. Initially these many elements, these elements are already visited. You do not need to calculate whether how much water will store in the boundary elements, because you are already marking them as 1. So I will just simply mark all of them as 1. Okay, so I hope this will be trivial and easy to understand. So yeah, I will just copy the same thing and do for the another loop, and this time my iterating variable, just for symbolic purposes, it will be j. Okay, and yeah, and it will go till, let's say, n minus 1, and yeah, j plus plus, and my height will be also this m minus 1. Okay, so the second variable is nothing but j actually. So yeah, this will be actually m minus 1, and this will be 0, this will be j, this will be j. So yeah, I hope it is clear to you, and the visitor also I will change accordingly. This will be j, this will be m minus 1, and this will be j. Yeah, so you will have the visited array also with you, completely ready, completely fine. Okay, so you have it. Now you have the complete heap ready with you. Now you can start with your iteration. Okay, so till what time I will definitely have a total variable which will store the total amount of water, and till not boundary is empty. Okay, so till the boundary is empty, I will just not empty, I will just keep on iterating through it. Okay, I will just keep on iterating through it. Yeah, so you have it. Now I will take the top element of my boundary. Okay, so I will just have an auto vector, which is the, let's say, the current cell. The current cell is a vector which will be of type vector, and let's say boundary dot top. Okay, I will just take it, boundary dot top, and I will also delete that element, boundary dot pop. So yeah, I do have the boundary element with me. Okay, now what I should do, I should tell, now this is the minimum height. This boundary element consists of the minimum height. If I store a vector of this priority queue, you already know that it will sort by the first element. Okay, so if you store in your priority queue a vector, by the first element it will get sorted. So by height, the first element is height, so the minimum height comes first. So yeah, so the minimum boundary height. Okay, so I will just write it in this way. The minimum boundary height will be nothing but cur of 0. Okay, and yeah, you have it. You have the row right now with you, which will be nothing but curve of 1. You have the column index with you, which will be nothing but curve of 2. Yeah, so you have these things right now with you. And what do you want? What do you want to calculate is the neighboring elements of this boundary. Okay, so you go through the neighboring elements, as I had already told you in this explanation of mine, that you go to the minimum element. Okay, you are going to the minimum element over here, and you are just now finding what are my neighbor elements and just trying to calculate their height. Okay, so I should go to my neighbor element at first right now. Okay, I should go to my neighbor elements, and so for that I have 4 neighbors, right? So yeah, I do have these 4 neighbors, and you see they are given by this direction. So one by one I will process the neighbors. So what will be the neighbor height? If I tell you what will be the row, okay, so how height will come afterward. What will be the neighbor row? It will be nothing but this current row plus this direction of I0, and this neighbor column will be nothing but current column plus this direction vector. I hope you do understand why this direction vector works. If you do not, just take a pause and understand why this works, because I am trying to iterate through all my 4 directions of the cell. Okay, I have already explained you this. Okay, so yeah, this is the thing, and I have my new row and new column, that is nothing but my neighbor row and neighbor column. And okay, so I want to say that if you see something like this neighbor row, is invalid. What do I mean by invalid? I will say that if it is less than 0, or this row is, let's say, greater than or equals to this m, or let's say this neighbor column is less than 0, or let's say this neighbor column is greater than or equal to this n, or if the if I am not stepping out, if I am staying within the limits, or if it is already visited. Okay, if visited is also true, so you do not need to do it again then. Okay, so for a neighbor row and neighbor column, okay, if this visited is true, then you can just continue. You do not need to see my rest of the loop. Okay, you do not need to see my rest of the loop. And for now I can calculate this neighbor height. This is nothing but I can get it from the height map, right? So yeah, I will get it from the height map, which will correspond to this particular row and column. So yeah, I got my neighbor height with me right now. And yeah, now what do I need to do? So you see, I have my neighbor height. Now you will see that my neighbor height should be less than the boundary minimum height. So if my neighbor height is actually less than my boundary minimum height, okay, uh, then I can store some water, right? How much water I can store? I can store minimum, I can store this minimum boundary height minus this neighbor height. So yeah, that's what I can store. And after this I will include this this cell also as my part of the boundary. So the cell which I just now explored, that cell I will include as a part of my boundary. So I will just do something like boundary dot push, and it will be a vector which will be nothing but, now you see, I need to calculate the max value here, right? Because you see the water height may also get incremented, and it will make it equal to the height of the minimum boundary. Okay, so I will just do maximum of minimum boundary height and the neighbor height. Okay, so there should be the maximum value. So there should, I hope you do understand this, right? There should not be any confusion. You see, this neighbor height may be very large, very large. The case where the neighbor height is large, we cannot store any water. Okay, and we can simply just then this if statement will not be calculated, and we will just store this n height. Otherwise, if it is very less, if it is very less than minimum boundary height, then definitely it can store some water, and that amount of water will also act as a height of the wall. So we need to take the maximum among these two. So I hope this is clear to you. Okay, there should not be any confusion. If you still have, you can definitely ask me in the comments. Okay, so yeah. Okay, so I have the height with me. I will have the neighbor row. I will also have the neighbor column with me. So yeah, I did push these elements into my priority queue, and this should work fine, I guess. You have also added into your total, and what you want to do is simply return this total. Okay, so I hope this approach was clear to you. There should not be any difficulty. You got the height, you just calculated whether it is less than my minimum boundary height. If it is less, I can store some amount of water. Definitely, I added that value to my answer, and also at the end I pushed this element. But one thing I forgot here, you need to make this visited of row column to be true. Okay, so you can just simply make this visited of row column to be true, meaning that you have already calculated this thing. Okay, so you have already calculated what is the amount of water which will be stored at this particular place, this particular coordinates. Okay, so you can just mark it visited. So I guess that should be it. If I try to run it and check if it works, or have I committed some error in between. Okay, so I am using some. Okay, so this will be height map, right? This will be height map. Okay, so let's try to debug this and see what are all the stuffs we are missing out. So yeah, similar things goes for here also. Yeah, so you see we do have the accepted thing, right? Now if you try to submit it, it will definitely work. It will just work out. There should not be any problem, I hope. Yeah, so you see there is no difficulty, and this was definitely a hard problem. So yeah, I hope you understood the explanation and the approach was very clear to you. This is the uh, main approach. Now you can go on optimizing this also, right? You see the runtime is not so good. For the optimization, you can do something like, you see, in your priority queue, you are storing a vector of the form of this, right? Height ij. Instead of that, you can use a single integer. Now you might be thinking that how can I store three integers in one integer? So you see, this is nothing but 200. Okay, so it will be less than an 8-bit integer. So this is how you can store. This is actually a cool trick in bit manipulation also, how you can store three integers in one integer. Okay, so let's say you have a, b, c, you are storing this as the vectors, right? So what you can do, uh, you take one single integer. In the first 8 bits you store c, you know c will be smaller than that. In the next 8 bits you store b, in the next 8 bit you store a, and you see if you push this whole integer into the priority queue, you will definitely be having this value is the most significant value, and this will be sorted by this. Okay, so in my case of height ij, I could have done that also. So I could have stored a cell which will be nothing but let's say I need to left shift this by 16 bits, so I just left shifted this a value to 16 bits. Okay, so I hope you just, this a value you can left shift to 16 bit, and you perform an OR to make this b value to 8 bits, and then you again perform an OR with c. Okay, so that's how you can make instead of a vector of hij, you can store a single integer with this trick, and I hope you like this trick actually. Okay, so you can just go ahead and try it on your own. Okay, so this will not be difficult, and the time complexity and all will definitely improve, because the whole complexity of your code is being reduced in that way. Okay, so yeah, you can just go ahead. I guess it's very trivial. The whole method is remains same even after doing that. So yeah, that's all for this video, I will say. Yeah, this was definitely a hard video, and hard kind of problem. And if you did not understand any portion, you are definitely free to ask me in the comment section. So yeah, that's all. I will meet you in the next video. Till then, thanks a lot.